Welcome to Physics Vibe YouTube channel, and this is Physics Classes with Ode again. This time around we're discussing Newton's second law of motion. We're trying to see how this second law of motion gives us force, presenting it as a product of mass and acceleration, and then a situation where the same Newton's second law of motion presents force as a measure of the change in momentum with time. So you just watch and let's see how we play around with it. Thank you. Now, for Newton's second law of motion, it states that the rate of change in momentum is proportional to the impressed force. So that F, which is the impressed force, is proportional to rate of change in momentum. This is a mathematical statement of the law. It says it is proportional to the impressed force and it takes place in the direction of the force. Now, given this law, we can proceed to factor out this and then see what we have, that F is going to be proportional to, we factor out, we have M, and then we have that what? V minus U all over T. You close this bracket. Recall from our previous classes that V minus U all over T is equal to A, acceleration. Now, in that case, you can now have that F is proportional to ma. This will imply that F is equal to kma. But conventionally, again, the unit of force is chosen such that k is equal to 1. So we can now have that F is equal to 1 times ma, and then it is equal to ma. Therefore, force is equal to mass times acceleration. This is where Newton's second law of motion presents to us force as a product of mass and acceleration. For force as a measure of change in momentum, we have that. Having written the mathematical statement of the law, mv minus mu all over t, we then say that to replace this with an equal sign, we bring our constant. So F is going to be equal to K and then mv minus mu all over T. But then again, we said the unit of force is chosen such that K is equal to 1. So we're going to have that F is equal to 1 times mv minus mu all over T. Then we can now have that finally F is equal to mu minus mv rather minus mu all over T. And this is a situation where force is given as a measure of change in momentum. Thank you very much for viewing Physics Vibe YouTube channel. Thank you very much for joining today's episode of Physics Classes with Odi. I hope you learned. Please subscribe for more videos. Thank you very much.